Hello everyone, and I am pretty certain that you must be pretty familiar with PID controller by now. Also, if not, do that first. In any case, let me give you a little bit of a rundown through PID controller, and then we'll get back to VBots again. Alright, so what is PID controller? PID controller is a control loop mechanism that is solely based on feedback and a target set point. So for now we have a system. That system will give output. It will also take input, and there will be a control loop, that is feedback, which will be fed back to it so that it can actually control things. So that is PID controller. And in PID, P stands for proportional, I stands for integral, and D stands for differential. And we scale all these three factors, and those three factors will be the gain of the PID controller, and that will be deciding the or tentative range for the PID output. So this is the basic. We put in the basic set point, and it does some computation. It does some computation from the feedback that it gets from the output, and then applies that error to P, I, and D, that is proportional. That is Kp times the error, or the scaled error. That is, the scale will be Kp and E of t will be error. Then integral, then again scaling Ki to the integral of error, and D, that will be differential, then scaling the differential, and then scaling the differential with Kd, that is, this part is differential and this is the gain, and then adding all these three together, then we produce the output accordingly. So that is basically PID output. Okay, so let's jump to VBots now. Okay, we are back here in VBots. I have already written the code for controlling the bot. For now, basically that will be following the line and then following the wall. For now, I haven't written the code for following the line using PID. We will be using if else for right now, but we will be using PID for following the wall. Okay, so I have got this code here in another text editor because the text editor of VBots is not as good. Okay, so let's look at the code. Here the first line, from controller import robot, so that is pretty basic stuff. Importing robot class, making a robot object, getting the time step, that is all normal. Okay, so the things that starts from here is, first we get the array for distance sensors, and this distance sensor value will take the values of the distance sensors, and yeah, that is we iterate over this loop once to get all the distance sensors in an array, and then enable them according to the time step. Same thing we will do for the wheels. We'll get all the wheels and then set their position and set the velocity to 0. Okay, now this part is related to PID. So as we discussed, PID is proportional, integral, and differential. So we initialize an integral variable, a differential variable, a proportional variable. Okay, also then we need a last error. This last error is a variable that will hold the error for the previous error, so that we can find the difference between the last and the current error. That will be helpful for finding differential. And also Kp, Ki, Kd are the three gains that are related to PID. Okay, for now just skip about the weight counter, that is not needed here. Okay, so we are defining these two functions here, that are a PID function and a set speed function. This set speed function is pretty basic one. It is just used to get the base speed and the balance speed, and it will do some basic computation and set the velocities to the respective wheels accordingly. Okay, that is very easy thing. For PID, what we are doing is we are using this global values. Why we are using global values? Because we are keeping track of integral, differential, and proportional. So proportional is not very global, but for keeping a track of integral and differential, we need previous values. So yeah, that is why we are using global values. So proportional is directly error. Integral is calculating all the previous errors and adding to it. So we are error is always adding itself to the integral. So integral is error plus integral. Same goes for differential. Differential is current error minus last error. That's why we initialize last error as 0. So that works how differential. Also finally then balance. The main PID thing is scaling the proportional with Kp, scaling the integral with Ki, and scaling the differential with Kd. and then totaling it all up to get the balance, and then updating the last error variable and then returning the balance. So this is the PID function. Okay, so now let's get to the while loop, that is the main control loop. So for this case, this is the main loop. So for this first for loop, this will update update the values from the distance sensor in a separate array, so that we can access it easier further. Now this first part, this if condition, it is mostly for line follower part. That's why using very basic if else statement for it. So that is very usual thing. The next, this else part is the one that we need to focus for now. So here what is happening is we are checking if there is nothing in front. So this will check if there is nothing in front, because we can't apply PID to the front. Okay, so whenever there will be front, it will try to turn towards right. That is just a random assumption. You can turn to the left if you want. For our case, we will be turning to the right, and this part is the main. So what we are doing is we are getting the error. So what is the error? This is the input value that we are providing in. This is the set point. As we discussed, this set point is 700, which I have decided arbitrarily, which can be anything under 1000, because after 1000 the distance sensor won't work. So it can be any value under 1000. So I have decided it to be 700. Then we apply PID over this error. We store it in the variable rectify, and then set the speed accordingly. So this rectify is the balance for us, and phi is the base speed for us. So yeah, that's pretty basic thing. So let's fire it up in VBots. So I have printed most of the stuff here, so it will be printing out in console, and let me just clear that. Okay, so let's run it. For now it is just using the line follower part, the if part. You can read it if you want, but that is not for concern right now. So yeah, right now it is applying PID, and whenever the value goes above 700, it will try to go closer to the wall, and whenever it goes too close to the wall, it will turn away from the wall, and that is how it is applying PID. In fact, it is going to continue applying PID even our track is over. So okay, we can also see some error going in the console. So let's discuss what that is. So since we are applying PID, we don't have a lot of control over what the output of this base speed plus balance or base speed minus balance will be. So sometimes it happens that it is crossing the threshold of plus 10 or minus 10, which is the limit in VBots. We can't apply more than 10 or less than 10 in less than minus 10 in VBots. So that is the error we can see sometimes. Okay, so that is that. Okay.